Welcome to Ask and Learn.
Welcome to the problem number 31.48. This is chapter 31, alternating current. So in this question we are given a low pass filter, and low pass filter is the series connected with our resistance and inductor, which are in parallel with our output voltage. So we are taking the output voltage here across the capacitor. Although these are in series, so these components are in series here, but we are taking the output across the capacitor. So we have capacitance C, so this is inductance L, and this is resistance R. So looking at this one, so we have V, which is across the voltage across the capacitance, which is equals to I XC. And we have current, which is equals to V over Z. Z is the impedance. So we have XL equals to omega L, and XC is equals to 1 over omega C. So we talk about the V out. So V out is our voltage across capacitance, which is VC. So VC, which is equals to I over XC, which is 1 over omega C. So this gives us V out over VS, which is equals to 1 over omega C. Now what is VS here? So looking at the relation again, so we have this formula here. So this is our VS. So we have I equals to Vs over Z. So we have Vs goes down here. So we have Z here. So this comes out to be R square plus XC minus XL whole square. So let me write it again. So this relation is as follows: V out over Vs equals to 1 over omega C under root of R square plus XC, which is our 1 over omega C minus XL, which is omega L whole square. So we are having a omega. So if omega is large, so we have Vs and ratio with our V out. So we have V out over Vs, which is equals to 1 over omega C R square plus 1 over omega C minus omega L whole square. So if omega is large, so we can just ignore this value here. So we can, because this factor will be small if omega is large. So this would become 1 over omega C under root of omega L whole square. So this comes out to be 1 over LC omega square. If omega is small, so we have V out over Vs equals to 1 over omega C R square plus 1 over omega C minus omega L whole square. So if omega is small, so we have this factor very small, and this factor as a large factor. So this would dominate. So this will become 1 over omega C And looking at this value, so this is very large, and we have square here, so definitely, so this will be a smaller number. So let's write it again. So we have r square plus 1 over omega c whole square. So omega is still small, so this is a smaller number in comparison to the 1 over omega square, smaller in comparison with 1 over omega square. So this will change to 1 over omega c times 1 over omega c. So this will come out to be 1. So we have an omega is large, x is small, x is large, so z is large, and the current is small. Both factors in Vc equals to Ixc are small. When V omega is small, x is large, and the voltage amplitude across the capacitance is much larger than the voltage amplitude across the resistor and the inductor. So that's the answer for this question. Thank you for watching the video.